available on that, your configuration that is on SD-WAN. Just try to connect and you'll get that. Okay.
Okay. क्योंकि अब अगर एक बार कोई cEdge भी हमें लैब में दिखा दे ना, it would be very useful क्योंकि cEdge में configuration would be different from all vEdges.
चलो I'll try to showcase you. Okay. Okay. So no worry. Let me get any cEdge access. So I'll try to give you that flavors. So okay. So let me just continue the session where we last time left that. So last time we have done the three kind of the policy, that is spoke and Hobbiness spoke based on TLOC, and extranet policy, that is route leak policy. So today we'll try to do some additional policy. Might be more we'll talk about the policy and the QS and TLOC extensions and DIA circuits. So let's say how much we are going to cover, but that session is very crucial to understand because we will focus on the majority part of the policies only. Okay, so just mute yourself. Who is not muted? Abhilash, let me just mute you. Okay, so now it's fine. So what I'm going to do, the first use case, what I'll try to do, the first lab which I'm going to demonstrate you guys, where we'll use the route based Hobbiness spoke. So two flavor we understand based on the TLOCs, based on the default. Now I'm going to talk about the route based Hobbiness spoke topology. Then how it is going to happen. So what I'll try to do in this scenario, my vManage will be the center point where I'll create the policies, and that is going to apply it on the vSmart, and that is going to enforce to all the vEdges. So in this topology, what I'm going to do, I'll block all the routings for these all devices. They are not going to talk each other because I'm just going to reject everything. So they cannot exchange the routing, but I will just allow the communication via the hub. So what is going to happen? My routing is going to block between these devices, these VSS, but they can still reach to the hub location and then they can communicate. So that is the objective of this lab. So that is known as a route based, Hobbiness spoke. So how I'm going to do that? Let me just show you. So in this lab, I'll go here and I'll create a new policy. And in this new policy, because the group of interest already we have defined based on the VPNs already available, 10 and 22 VPNs we have, an additional site we have, and other information not required. So what I'll do, I'll just go and click next. So here I'll go and click next. And after clicking next, I'll go in the topology, and here I'll add the new topology based on the routes. Okay. And custom, and I'll make a name route based hub and spoke. So I'll just copy this one. And after copying this, I'll go there and I'll just simply select the route. And after selecting the route, I'll go in this sequence. And in this sequence, I'll just match any site that would be the spoke site. So you can see all spoke site having 3 sites. So these are the 3, 4, 5. And I'll select the spoke site, and also I select the VPNs. So there are 2 VPNs, 10 and 20. So I want only VPN 10 should be, block all traffic between these sites, but VPN 20 should be the full mass. So VPN 10 is only going to reject between these 2 sites, these 3 sites, and other things apart from VPN 10, they will work as a normal. Let me show how it is going to happen. Just give me 1 second. Having cold today. Okay, sorry. So in this situation, what I'll do that in our topology, I'll just block the communication for VPN 10 and remaining VPN, I'll leave it as it. And even I want to go with the VPN 20 also, I can do that. But here I'll just select the one VPN, that is a VPN 10. I'm not going to select that other VPN. And I'll just, if I save here, that is going to be match action. But I just matched the situations, but I didn't define anything in action. So I just matched the spoke side and the VPN 10. In action, what I'm going to take, reject all the routes. That means if any route is coming, from VPN 10 between these sites, just reject all the communication. This is the action. I'm not going to accept this. I'm just going to reject them. So this is a default setting. I'm just going and save here. So in this situation, you can see that I'm saying that any spoke sites which have in the VPN 10, if they want to communicate, just reject them communication. I'm not going to allow them. And the default action, because default action should be accept to pass other traffic. So I'm going to accept this, as the black hole is going to happen, no traffic is going to pass. So it is going to accept. So you can see the first sequence, I'm rejecting all the traffic between these three sites. And then I'm going to save this control policy. And after saving, I'll click the next. And after clicking the next, I'm going to not going to do anything here. I'll just go next and apply the same policy to site list. So which site list I want to apply? So that is I'm going to outbound site because it is going to apply for all sites. So I'm going to apply all the spoke sites only, not the hub sites. Okay. So I'll just add here and I'll see, I can see the preview of the policy. So in this policy, you can see that the first I'm saying route based hub in a spoke. And in this situation, I'm thus matching the spoke sites and for the VPN 10 and any prefix if it is matching between these sites for VPN 10, the action is going to be reject and default action is accept. And the site list we having 1, 3, 4, 5, VPN is 10, prefix is any, and we just apply to all the spoke sites in a outbound direction. So I'll just save this policy. Okay. So my policy has been saved. So here is my policy. That is the route based hub and spoke policy. Then after, before I apply this policy, let me just show you how it is happening right now. So if I'm going on the VS3, and in this, I'm just going to change this a little bit, 8, and let me just show. So OMP route. So you can see right now in this topology, in current scenario, all the routes I'm getting for the site 4 and site 5, I'm directly getting from these sites. You can see that directly I'm getting. So they are directly, that means my topology in the full mass for timing right now. That's why I can see all the routing. So if I want to trace from this router to this router IP address, so see it is going to be side to side. Let me just perform one trace. So trace route, let me just try to ping first. Ping 14.14.14.14 with the source 13.13.13.13. It is not pinging. It is pinging. Okay. So let me just trace it and see how the trace is going on. So now, sorry guys, I was on mute. So now you can see the trace is going via this site directly from this to this, and it is landing to this location. Let me show you. This site is going and it is landing from this to directly this. You can see this is a subnet and it is reaching to destination, that is a 14.14.14 configure on the site 5. So this is the full mass topology right now I'm able to see here, and that's why my output is this way. But if I apply this policy, this is going to be changed. This behavior is going to be changed. So how it is going to change? Let me just go and activate the policy. So this is my policy I just created right now, and it is false. So let me just activate this policy. Then we'll see that how the things is going to happen. So if I enable this policy, by default, all the VPN 10 for a spoke site, they stop the exchanging the routes. They will stop the exchanging the routes. So then communication is not going to be happen. So see, my policy has been successfully committed, and then after I'll just go there and again I try to check the routing here. I run the same command, and you guys see that the routing table has been suppressed, and we don't have any route for VPN 10. So see that VPN 20 having the routes, but VPN 10 doesn't having any route for site 4 and site 5. There is no route. So that means we are not able to reach for site 3 from site 3 to site 4 and 5. So if I try to just ping again from this, it should be not pingable. See, the traffic has been dropped. So right now my route based policy has been applied, but how can I reach to this site again? So again, I have to go there on this particular vEdge, and I have again put the some kind of default route, so that at least the last gateway or resort should be available what we have done in the very first lab. So this is another kind of the solution to perform the route based VPN. So here I'll go there again, and after going in the configuration, I'll just copy this and I'll go on the VPN 0, and I'll just put a null 0 route here. I'll just commit it. Okay, after committing, you might be find another route in this routing table with the default route from data center. So let me just show you again. So here you can see that now still we don't have, probably it will come. So run VPN 0. Okay, sorry, I made a mistake. Okay, that should be not in the VPN 0, that should be VPN 10. Okay, that's why I'm thinking what I have done wrong. So what was the routing? Let me just correct this. I made a mistake. So 192, what is the next hop for this particular transport? 1.1.1. So this should be not on the VPN 0, should be the VPN, because we are talking about the VPN service VPN 10. So let me just go there. And here I'll go. So I'll go there and I'll just go in the VPN 10 and IP route 0 null 0 and commit. So now if I go and check here, we must have the default route. You can see VPN 10 default route is there because that route should be available in the VPN 10 only. Okay. So if I go again and try to ping from this one, so probably we having a reachability. You can see that, but this time if I try to trace, it should be not going to direct from spoke to spoke, it should be go by the hub and spoke.
You are not able to. You are not audible.
Okay, sorry. So right now you can see the traffic is coming from 13.13 series IP routers, and it is going to that 5.6 that is configured on this particular interface. And then after it is reaching to the spoke that is 5 sites. So this is how your topology has been changed based on the route base. So if you want to do this kind of the play for the policy, you can do that. Okay, any doubt anyone having on this kind of the policy, or it is clear to everyone? Okay, all right. So I'm just assuming everyone is clear. So what next? So now I'm going to tell you, if let's say suppose I'm sitting on this site and I want to reach any of the site destination address or any of the destination address. So how it is going through along with the transport, because they will doing the ACMP. So we're having another provision that is known as the application aware routing. So if I want to perform based on the application, I want if one application traffic should go with this link, but another application traffic should go with another link. And then how it is going to happen based on the policy. So first, let me just tell that behavior about the from vEdge perspective. So I'm going on the VS3 from that GUI, and here let me just go there. I'm going here. And let me go and open this VS3. So this is something we are going to interact with the live session and troubleshooting and checks via the GUI instead of the CLI. And this is the best way to do the troubleshooting. So I'm going on this, and I'm going on the real time. And after real time, you're having a section of the troubleshooting. So if you go in the troubleshooting and you having option to simulate the flow. So that means there is a ping also and trace also. But if you want to simulate the flow, that means you want to just check how my traffic will go, which link it is calling, just simulating. It is not going to generate anything, but it will just simulate the flow, how your traffic is going on. So let me just check one flow. So I just click on the simulate on flow, and in this flow, what I'm going to do, I am going to generate one traffic from, might be from VPN 10. Okay, because I'm just trying to generate from traffic from VS13 from VPN 10, and I want to use the interface that is a source of VPN 10, that is the 10.3.13.1. This is my source, and this is my source IP. And let's say suppose I want to go on destination 15.15.15, that is site 4. So I'll just put the destination 15.15. Okay, then we having the advanced thing also. So I'll just select the advanced. So it is asking from which path you want to take, tunnel or service. So I'm talking about the service VPN right now, because we selected the service VPN here, not tunnel VPN. That is the transport one. So I'm just going to select the service VPN. So here service VPN is there because I'm originating the service VPN traffic. Then it is asking on which protocol you want to generate the traffic. So I use the protocol number 6, that is a TCP protocol. So I'll just use the 6 protocol. You can use any number of protocol for which you want to test. Just I'm doing testing for the TCP. And what is your source port? So I just, because source port the random ports, so I'll just use any source port 1, 2, 3, 4. It is a random one. But here a destination port. So I want to check telnet traffic as a destination for port 23. So what I'm trying to say, I'm sitting on this site on this vEdge router, and I want to telnet this particular IP with any random source for the TCP application. I want to check how the traffic flow is going on along with these two transport for telnet traffic. So let me show you how it is going on. So if you click the simulate the packet flow from here, so you can again see here, I have just used the service VPN, source interface, source IP, destination IP, and the protocol, that is a TCP. And the source port I have taken the random, but destination for which application I want to, access. So that I'm selecting the TCP, telnet port work on port 23. So I just selected the 23 port number. Then I'll click on the simulate the packet. So I'll just click the simulate the packet. And you can see that it is clearly showing your traffic is passing via the both of the transport. You can see it is saying, hey, your traffic for telnet for this site is going via both of the transport, via the public internet also and via the MPLS also, because it is doing the ECMP. By default, ECMP. That's why your traffic is going via the both of the transport. So this is one scenario. Similarly, if I want to check for the port 80, that is HTTP traffic, then let me see how it is going on right now. So you can see right now it is again going via the both of the transport. So this is the normal behavior. Right now my traffic is passing via the both of the transport to reach to this destination. But I want, because based on the application aware routing, AAR having the feature, application aware routing told us, if you want some application want to go with some specific link. So I want port 23 traffic always go via the internet to reach to this destination. So that should be the public internet. And port 80 traffic should always go via the MPLS. So this is my requirement. And if this public internet goes down, then it fall back to the MPLS. And if the MPLS goes down, then it fall back to the public internet. But in ideal scenario, I want this router recognize the application, and based on the application, it always send the traffic for the telnet via the internet, and always for the port 80 or HTTP traffic or HTTPS traffic via this router that is known as the MPLS. So everyone understand the requirement and current flow, or anyone not understand? Let me know.
Yeah, hi Pankaj, Manoj here. So I joined also something late. So could you explain again?
So I'm saying we having one feature in our SD-WAN that is known as the application aware routing. Okay. So in this application aware routing, what is happening? Let's say suppose we having a dual transport, dual TLOCs. Okay. So if I want some of the application traffic always go via this transport and some of the application traffic always go via this transport. So this can we do that by using the policy. Okay. And but if this transport goes down, so all the traffic start going via this only the live transport. So in our scenario, also we having a two transport, that is MPLS and internet. So I want half of the traffic, or not half of the traffic. Actually, I want my telnet traffic or any other traffic will always go via the internet circuit to reach to destination, but my SAP traffic, HTTPS traffic, HTTP traffic, that always go via the MPLS circuit. So that is my intent. So right now I have not done any configuration. So you can see that it is doing by default ECMP. That means it is using power flow and the traffic is going via both of the links. By default it's doing the load balancing. But I don't want to do this because I want my internet traffic should already handle the internet-based applications, and my MPLS traffic only handle the MPLS-based application. But in case of failure, they also cater both are type of the requirement. So this is my requirement. So let me just capture this output and we'll just verify later how the requirement has been changed after applying the application aware routing policy. So I'm just capturing this one for one output for our reference, and later we'll verify this. Okay, so leave it. So what I'm going to do, the first thing what I'm going to do, I'm just going on vManage, And after going on vManage, I'm going on the policy. So let me just go there in configuration, and I'm going in the policies. After going in the policy, I'll add one policy. Okay. Here, before adding the policy, you have to define some SLA classes. Okay. So here you can see some predefined SLA classes. I have just tested, might be some time ago, and it is showing that if you want to go telnet, you can use this one. If you're going web, you can use this one. So let me just try to delete one. If this can be deleted. So it is not deleting. Let me just delete from somewhere else. I'll create from very basic. Let me topology. No. Traffic policy. This edge cannot be deleted. List. Okay, no problem. Let me just create a new one. Somehow not able to delete, so I have to check from where I can delete. Should be there somewhere. CLI policy list traffic, but never mind. Let me just click next. I'll create a new one. So I'll add the policy, and here I'm going the SLA class. So just forget about this. I'll add the new SLA class, and this time I'll use the SLA class is known as the port 23. Okay, the meaning is same as the telnet. Okay, and here I'm going to say if there is a loss latency of any application that is going through any link, that should be switched to another link. Okay, so how it is going to happen? So I can define, let's say suppose both links are idle. Okay, so right now I just force the traffic should always go via this way. Okay, but if this link having a latency, jitter and loss, then it will fall back to this link. So for that, I'm just defining the SLA classes. So in this SLA classes, what I'm going to do, I'm going to define port 23 telnet. That loss might be going to 20%, or my latency going to more than 350. Okay, ms, or jitter could be like 500. Okay, or like might be the 600. So this is my just group of interest. I'm defining the criteria. It is going to be used as a action later. So I'm just defining likewise the site and VPN we have. So I just defining the this particular things telnet. Similarly, I'll go here and I'll define that port 80 could be the web traffic, and here again I'll define might be my loss will be this 15%, this would be the 400, this would be the my 300. Okay, so I'll just add criteria could be anything you can define as per the customer requirement. So I see I use these two group of interest as a service SLM, and now we having the TLOCs, we having the VPNs, we having a site already in place. So nothing other parameter is going to required. Application is also not going to required, but if required, we can use the application also. So my group of interest has been created because we need a SLA class while achieve this particular lab. So I'll just click next, and after doing the next, I not have to do anything here in topology and VPN membership. So what I'll do, I'll click next, and here you can see we having option to define application aware routing. So after defining the application aware routing, what I'll do, I'll just click and create a new application aware routing, and I'll give that application aware routing. This could be the my
we can define any name, right?
any name. You can just put AAR if you want to use short name. So you can
suppose that we have one data center, so we can name the data center name, which is the one, so no two link, right?
Yeah, definitely you can use based on your need. There is no any
Yeah, because the organization requires some customizations name according to architecture.
Yeah, that should be the well-known name, so easily you can understand what you are doing, right?
Yeah, all right.
Okay. So after this, what I can do, I've already defined the group of interest, and then after I just wanted to define some kind of the SLA. So let me just go there and define the SLA and all. So what I can do, so yes, so this name has been done. So I'll just click on the sequence. Sorry. So I just click on the sequence, and you can see here we having option to app route, which I want to define. So I'll just click on the app route, and then probably we'll get the new window. So here I'll click the app route, and now we having option. What I want to do. So the first thing, I want to match TCP based any application that having the protocol number 6. So I just selected the protocol as a 6. So I just use a TCP protocol 6. So that is the first criteria I want to match. I want to match all TCP based applications which is going to be communicate via this particular vEdge or any site. So that is a protocol number 6. And then I want to define the destination port to which this application is going to be talk. So I can use the destination port, and I can use any port number for which I want to use. So we having a 2 ports. One is the port 80, one is the port 23. For two I want to use. So for here I'll use the port 23. Then after defining this, I want to see what actions shall I take to make this working. So the actions would be, if I go and check the action, then it is asking what SLA class list you want to call for this particular 2 applications, like one application, one port. So I'll select the application list, and it is asking which application class you want to check. So we created this one, telnet or web. So we are matching the port 23. So I'll select the telnet. Then it is asking for this application, what is your preferred color? So what I want if this telnet application is going to match, the preferred color should be public internet, okay, to reach to another site. So I'll go there and I'll use that, the public internet. So where is my public internet? So here is my public internet. Now there is one option, restrict. So I've clicked this restrict option. That means this public internet color can only fall back to the public internet. But in this site, we having a 2 transport. One is the public and one is MPLS. So in case this link having high latency, high loss, so it is not able to fall back on the MPLS. It is not going to fall back over the MPLS if I click on the restrict action, strict action. So I'm not going to restrict this. I'll leave it. If in case this link having any issue, that should be automatically fall back to the MPLS. So this is the meaning. So I'll just click save and match. Or also I can use the counters if I want to use like any counter I want to call, but here it is not really required. So I'm not going to use counter. Probably in the QS will require this. So I'll just save and match. So the first condition I have defined here. So for port 23, I have defined there. Now, similarly, I'm going to tell for the port 80. So I'm going to use again the protocol. That is my protocol number 6. But here the destination port is going to be changed. So what is my destination port? So here my destination port, here I'll go and use the port number 80. And for this, I'm going to take action and I'm saying match the SLA class list. That is the web. And for this, your preferred color is the MPLS. So this traffic always go on the MPLS, and also I'm not going to restrict here, because if I restrict, it always try to fail back on the MPLS color, but that routers doesn't having any MPLS color. So it is not going to happen. So I'm not going to restrict. So in case there is some jitter, loss, latency based on this SLA class, it still can fall back to the internet. So I'll save this. So this is saved. My 2 condition has been defined. In default action, what I'll do, I'll go and like it already enabled, so no need to do anything. So SLA class, no, none, leave it like default one. So it is enabled, nothing should be defined. So now I'll just go and save this policy. So this thing has been done. After doing this one, what I have to do, I have to define the next thing, that is the condition for which this application should be, apply. So now I'm going to next, and after going to the next, I have to use the name again, what I used the earlier, application aware routing. And here I'll go in the application aware routing tab. So just click in the application aware routing. And now you have to define for which site and which VPN you want to apply this particular policy. So right now I'm doing testing for site 3. So I'll just go and apply for site 3. Similarly, you can apply for all sites, but we just have taken a capture from site 3. Concept is going to remain same, but you can apply to any site. So here for the lab, I can go and I'll apply that the site branch 3. And for VPN 10, we have done testing. So I'll use the VPN 10. So this is, I have just applied. There is no direction would be required, and I'll add this. After adding, I'll preview the policy. So you can see this is my policy. And what I'm doing, first thing I'm doing that I'm defining the SLA class, where I'm saying if latency is more than 350 or equal to 350, if loss is 200 or jitter is either condition is going to match, then you have to take some action based on this action SLA class, not this one, basically this one. And if the preferred color is a public internet in ideal scenario, but if this is going to breach any threshold, then you have to fail over to the MPLS. Similarly, this is for the MPLS. If these are the breach criteria, if preferred color is MPLS, but it is going to be more than 400, loss is 1500, then you have to fail back to the public internet. So this is how your policy has been configured. So it is going to apply for site 3 and VPN 10. I'll save this policy. So now my policy is ready. Before I'm applying to the policy, let me go again and take the same thing what we have done earlier. So I'm going there. After going, I'm going the VH5, and after going in the VH5, I'll take the VH3 and I'll go in the real time. And in real time, what I'll do, I'll go in the troubleshooting and I'll simulate the flow again. And I'll use that VPN 10. VPN 10 is the source this, source IP this, destination this. I'll go in the advanced, from this could be the 6 and source port anything, and could be the 23. So right now you can see before policy is not applied, it is going via the both of the color. But now I'm going to activate the policy and we'll check how this is going to be changed. So let me just go on the policy again. And after going in the policy, I'll go this application. Yes, this policy, and I'll activate it. So let me just activate it. So the policy is progress and activity. So this has been activated. Now let me go on this dashboard again. And after going on the dashboard, I'll go again on the vEdge and I try to simulate the package from the real time. I'll go in troubleshooting, simulate the flow, and here we should have some different output this time because our policy is applied. So let me just check again. I can take any random port, but destination port is 23. And now simulate the flow. Now you can see the magic. Now it is forced to go only one color instead of the another color. So this telnet traffic is just going via the public internet, not MPLS. And if I change to the port 80 that we define to the MPLS, let me just simulate. This is going via the MPLS. You can see this is going via the MPLS. So any source port could be the anything. So earlier I have taken 1, 2, 3, 4, 5. You can take 1, 2, 3, 4, 4, any number. Still For destination, it is keep going to the MPLS. So this was the earlier output for the port 80. You can see that 1, 2, 3, 4 on port 6. It was going by the both of the color, but now it is only preferred color is the MPLS. Till the time we don't have latency, jitter, and loss on this link, it is keep going on this link. But if the loss, latency, jitter is going to be high on this link, it is going via the public internet. So this is the beauty of the application aware routing. So you guys are
okay, sir.
Haji, tell me.
Sir, when the link quality will be good, then it will be automatically shipped to the primary link.
Yes, definitely. No need to do anything. It will automatically, because it having the deep packet inspection, and they maintain the cache and statics for the all links. They keep monitoring based on the SLA, so it will automatically ship. No need to do anything. Okay.
Yes.
So
sir.
any question, anyone having any anything you want to check from here? Similarly, if I go to 1414, let me just check for other destination also. It should be the same flow. Let me just check for 15 to 14. Let me just simulate. It always be the MPLS, regardless of the any destination. From this BH perspective, when the traffic is going, they just match the all the policy what we enforce, and it always follow the same rule. So if I change the port 80, it is going to be MPLS. Let me change the 23. Why it is taking the MPLS? Should not. This time should be internet, right? Port 23. Why it's giving this behavior? Let me check it again. It's the public internet. 14. Oh, I got it. Why it's taking the MPLS? Because this site having just one link, MPLS only. You can see that this site having just one link. So that's why it's no choice. They are just, this route is just reaching to this site via the MPLS, not internet. So that's why it's taking the MPLS only. Instead of even you do the, matching an SLA class, but this site, all route is coming by the MPLS. So no way to get out to the, internet. So ACMP only work when we having a 2 copy from different or like multiple copy with a different transport. But for this, it is coming for the MPLS. That's why it's showing the MPLS only in the simulation also. So no need to worry about that. All right. So this is the application aware routing, and this is the concept, same concept what I explained. We can define that. Let me show. This is the same definition. If having a loss, latency, and jitter for the multiple path. So if path quality is going to be degrade, your traffic is going to be shipped some another path. So you can see vEdge routers continuously perform the path liveliness and the quality measurement based on the SLA class what we have defined. And if their latency, loss, and jitter is going to be more than whatever the threshold we have defined, then the auto failover is going to happen for that application. No need to worry about that. So this is the beauty of the application aware routing, and is the very powerful feature we having in the SD-WAN. All right, so hope you guys understand. Now the next thing what I'm going to talk is very special, that is a DIA, direct internet circuit, which is if we having on the routers. So what that means, so before going to talk this one, let me just talk a little bit about that. The normal behavior of the DIA, how the